Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we're looking at how you integrate functions of the form some function of ax plus b. Now, if you have a function of that form, what we're essentially doing is using the chain rule in reverse. So if we had to differentiate that, first of all, we'd differentiate f, and then we'd multiply by the differential of ax plus b. We do the opposite when we're integrating it. So we integrate the outside function f, and then we have to divide by the differential of ax plus b. Once you've done that and got your answer, it's always a good idea just to differentiate your answer to make sure you do get the question. For example, if you had to find the following integral, the integral of the cosine of 5x minus 2, first of all, we'll be integrating cosine, and then we'll have to divide our answer by the differential of 5x minus 2. I'll let you have a go at this yourself first. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So first of all, we need to integrate the cosine. If we integrate that, we'll get sine of 5x minus 2. But if we did differentiate that, we'd differentiate the sine and get the cosine that we want, but we'd also have to differentiate the 5x minus 2 using the chain rule. So we'd also have to times by 5. Because we're integrating, we need to do the opposite to that. So we'll need to divide by 5. And that will give us 1/5 of the sine of 5x minus 2 plus an arbitrary constant. It's always a good idea with integration just to differentiate your answer very quickly to make sure it does take you back to the question. And if I differentiate this, I will get 1/5 times by the cosine of 5x minus 2, I differentiate the sine, times by 5 when I differentiate the 5x. And the 5 and the 1/5, they cancel each other out. And they always should do on this type of question, leaving you with the cosine of 5x minus 2, which is the question we wanted. Okay, example 2. This time we're integrating e to the 3x plus 4. So the outside function is the exponential function e. We'll need to integrate that first of all, and then we'll need to divide by the differential of 3x plus 4. Have a go, pause the video, come back to me when you're ready. Okay, let's have a look. So integrating e, first of all, well, when you integrate e, nothing changes, so it'll stay as e to the 3x plus 4. But if we were differentiating that, we would have to, first of all, differentiate the e, but then we'd also have to multiply by 3 when we differentiate the 3x plus 4 using the chain rule. We need to do the opposite, so we need to divide by 3. And that will give us 1/3 into e to the 3x plus 4, plus a constant. And again, if you differentiate that, we should get the question. Differentiating it gives us 1/3 e to the 3x plus 4 times by 3 when we differentiate the 3x. Again, the 3 and 1/3 cancel, giving us the question. So all is well. Example 3, find the integral of sec squared 5x. So we'll need to integrate sec squared and then divide by the differential of 5x. Pause the video, have a go, come back to me when you're ready. So integrating sec squared gives us tan, so we'll have the tangent of 5x. But if I differentiated that, I'd also have to times by 5 when I differentiate the 5x. So I need to do the opposite. I need to divide by the differential of 5x, which will give me 1/5 times by the tangent of 5x plus c. And if I differentiate my answer, differentiating that gives me 1/5 sec squared 5x, again times by 5. The 5th and the 5 cancel, and that takes me back to the question. Okay, example 4, slightly different type of question. We've got the integral of 4x minus 3 squared. The squared is the outside function. So you'll need to integrate the squared first, and then divide your answer by the differential of 4x minus 3. Have a go, pause the video, and come back to me when you're ready. Okay, let's have a look at this. It's an important type of example, this one. First of all, it's the squared that we're going to have to integrate. So the power will go up by 1 to 3, and we'll have to divide by the new power. So we'll have 4x minus 3 cubed, and then we have to divide by the new power, so divide by 3. Then we also need to divide by the differential of 4x minus 3. So if we were differentiating that, we'd be timesing by 4. Integrating it, we need to divide by 4. And that gives us a third times by a quarter times 4x minus 3 cubed plus c. Simplifying that gives us 1/12 into 4x minus 3 cubed plus c. And if we differentiated that, we would get the question. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 150 and have a go at exercise 7D. Thank you very much for listening, and cheerio.